Ga. This is a multi-billion-dollar ghost in the desert. A 100-story monument of pristine glass and steel, rising hundreds of meters above the Dubai Marina skyline, completely empty. The tower they whispered about in the executive boardrooms of downtown and Business Bay. The one that was supposed to redefine ultra-luxury living on Earth. Designed by elite Western architects and funded by an ambitious British Emirati consortium, this megastructure was already piercing the clouds when the ground beneath it literally began to fight back. The problem wasn't a lack of capital, though the sheer cash burn nearly bankrupted the developers twice. The problem was the very earth it was built on. Millions of onlookers see a flawless architectural marvel. But beneath the polished marble lobby lies an engineering nightmare, sinking reclaimed land, and aggressive marine calcification. Construction ground to a sudden halt. The blueprints were violently ripped apart, and the lead structural engineers had to answer a terrifying question that no simulation could prepare them for. How do you stop a billion-dollar skyscraper from slowly drowning in a desert? How does a luxury icon become an existential crisis, forcing a supertall to completely alter its structural DNA mid-construction? To understand this catastrophe, you have to look at a Dubai that was moving faster than physics allowed. This tower was meant to be the crown jewel of the marina, boasting the highest residential penthouses in the region. But it was born into a hyper-accelerated gold rush. The goal was to transform coastal sand and shallow Persian Gulf waters into a dense forest of luxury high-rises almost overnight. Hundreds of towers. And at the epicenter, a megastructure designed to push the absolute limits of civil engineering. If investigative breakdowns of engineering disasters, where nature humbles human arrogance, are what you want, hit subscribe. Now, back to the coast. Because before the saltwater started winning, the sheer scale of the ambition almost broke the project. To trace the roots of this crisis, you have to rewind the timeline to the initial groundbreaking. In the early planning phases, the site was hailed as prime real estate, a premium plot sitting directly on reclaimed land along the shifting coastal fringe of the marina. But building a supertall on sand isn't like building on bedrock. The technical timeline reveals a sequence of compounding delays that stretched the project out for years, turning a fast-tracked luxury build into a grueling war of attrition against the elements. The first major bottleneck struck during deep excavation. Engineers had to drive hundreds of friction piles deep into the marine sediments, tracking every millimeter of settlement. But then, macroeconomic shocks hit the region. Global liquidity dried up, and funding for the wildly ambitious tower evaporated overnight. The site sat completely dormant for nearly 4 years, a massive deep pit exposed to the coastal elements, filled with stagnant groundwater and corrosive sea salt. When capital finally flooded back into Business Bay and the project resumed, the engineering team faced a brand new reality. The market had shifted. To maximize return on investment, the developers made a critical decision. The tower needed to go higher, adding an extra 15 floors of ultra-luxury penthouses to the blueprints. But the subterranean foundations were already set in stone. They had been engineered to distribute the load of a significantly lighter building. Enter the structural engineering specialists brought in to solve the impossible. The mandate was brutal: make the tower taller, but somehow shed 10% of its dead weight, so the existing pile cap wouldn't crack or sink into the soft earth. The team completely re-engineered the building skeleton mid-cycle. They swapped out heavy reinforced concrete partitions for a high-strength composite steel outrigger system and thinned the internal core walls. It was a brilliant structural compromise that saved the foundations from immediate failure. But it opened the door to an even greater environmental vulnerability. As the lightweight tower rapidly climbed back into the intense heat of the sky, the true physical toll of the coastal desert environment began to manifest. The engineering was holding up, but the materials were about to reach their absolute breaking point. As the redesigned tower shot upward, it began to parallel the structural vulnerabilities of other megastructures across downtown and the Palm. The engineering team quickly discovered that changing the building's skeleton to save the foundations triggered a cascading nightmare higher up: extreme glass fatigue caused by Hyper-accelerated thermal expansion. In the climate of the UAE, coastal skyscrapers act as giant vertical mirrors, baking in direct sunlight. Temperatures on the exterior glass facade can easily rocket past 70 degrees Celsius during midsummer peaks, while the interior is blasted with heavy, freezing air conditioning. This creates a violent thermal gradient across the building's envelope. Because the tower's perimeter had been lightened and thinned to protect the foundation piles, the building lacked the massive thermal dampening of traditional concrete structures. The glass wasn't just sitting there. It was actively expanding, contracting, and flexing under immense physical stress. Worse still was the invisible threat of glass fatigue. Microscopic imperfections within the glass panels, specifically nickel sulfide inclusions, react violently to rapid temperature swings. Combined with the relentless pressure of coastal winds whipping off the Gulf, panels began to fail. It wasn't a slow cosmetic degradation. It was sudden, catastrophic shattering, showering the upper mechanical levels with crystalline debris. At the exact same time, a parallel crisis was brewing at the base of the tower. The reclaimed land beneath the marina is highly porous. As the tide shifts, pressurized salt water forces its way through the subsurface sand, constantly testing the building's subterranean waterproofing membranes. The extended years of abandonment during the financial freeze had allowed salt-heavy moisture to pool around the lower basement retaining walls. Microfissures, invisible to the naked eye, began to weep. The desert heat was expanding the superstructure above, while a silent, corrosive chemical assault was eating away at the barrier seals below. The tower was trapped in a mechanical vice between thermal stress in the stratosphere and high-pressure marine moisture at sea level. Behind the corporate press releases and the complex load calculations lay the human cost of a supertall pushing past the limits of physics. As the structural issues mounted, the reality on the ground became impossible to hide from the elite teams tasked with executing the impossible. David, a veteran British facade consultant who had spent 2 decades engineering premium glass systems across downtown and the Palm, was brought in to inspect the upper levels. His initial assessment was chilling. Walking through the skeleton of the 95th floor, the sheer velocity of the thermal expansion was audible. In the dead of summer, as the desert sun baked the exterior to blistering temperatures, the lightened structural steel outriggers would groan and pop as they flexed against the air-conditioned core. He recounted sleepless nights, tracking the microscopic movement of the facade panels, knowing that a single millimeter of miscalculated tolerances could cause an entire row of luxury glass to buckle and shatter into the marina below. Meanwhile, deep in the subterranean dark of the basement levels, a completely different battle was being fought by Tariq, a senior site engineer overseeing the waterproofing recovery. While the world looked up at the glittering crown, Tariq was looking down into the muck. He described the suffocating heat of the lowest basement levels, where the constant, high-pressure hum of heavy dewatering pumps served as a frantic heartbeat, keeping the tower alive. The reclaimed soil was so saturated with salt water that any failure in the pump grid meant immediate flooding. He watched as aggressive marine calcification began to coat the newly exposed foundations. White, bone-like salt crystals eating into structural seals. The pressure from the high-net-worth buyers who had dumped millions into pre-construction deposits for the ultimate luxury penthouses was immense. They demanded answers for the mounting delays. But how do you explain to an international billionaire that their infinity pool in the sky is currently delayed because the entire building is wrestling with intense glass fatigue and a sinking perimeter? The engineers were caught in a brutal vice, forced to accelerate construction by corporate management, while fully aware that the physical environment was pushing back against every single square meter of the design. It was a high-stakes poker game played against the laws of thermodynamics and geology. Today, this 100-story icon stands as a silent monument to the razor-thin margin between architectural triumph and environmental reality. The engineering team successfully stabilized the foundations and reinforced the facade, but the building faces a permanent, long-term operational risk. In the hyper-luxurious sectors of the Dubai Marina and Business Bay, a tower cannot simply survive. It must function perfectly. The future risk isn't sudden collapse. It is the relentless, daily toll of maintenance against the desert coast. The extreme thermal expansion cycle repeats 365 days a year, continuously wearing down the structural sealants. The high-pressure saltwater beneath the reclaimed land never stops pushing against the basement walls. If the massive dewatering systems or specialized climate controls fail for even a few days, the internal systems risk rapid degradation. Furthermore, the economic reality of empty units and high vacancy rates across super-tall developments looms large. When multi-million-dollar penthouses sit unoccupied, the immense capital required to fund high-tech, proactive maintenance begins to dry up. A building of this scale requires constant, aggressive human intervention just to keep nature at bay. If you appreciate the technical truth behind these megastructures, where the engineering is a never-ending battle against the elements, hit subscribe. Tell me in the comments, would you buy a luxury property built on reclaimed coastal sand? Or does the physics of glass fatigue and sinking soil make you look at the skyline differently? The architect's vision was to conquer the desert and the sky. What this tower proves is that you can pour billions of dollars into the sand, but the most powerful force a skyscraper must withstand